In this video, I'm going to do a quick review of evaluating functions. So let's take a function such as f of x is equal to 3x squared plus 2x minus 1. This would be a quadratic polynomial, and you can take a look at my quick math video on quadratics if you need to brush up on that a little bit. Let's say we want to evaluate this at 2. We would write f of 2. Now, this is a function f. The f tells us the name of the function. 3x squared plus 2x minus 1 is the rule of the function, and x is the independent variable. The rule of the function tells us what we're going to be doing to the independent variable. For instance, we're going to square it, multiply it by 3, multiply it by 2, add those together, subtract 1. So the name of the function is f, the independent variable is x, and this is the rule. So this is telling me that I want to evaluate it at 2. In other words, replace the independent variable x with a 2. So that would look like this. 3 times 2 squared plus 2 times 2 minus 1. And now it's just a matter of simplifying this. So 2 squared is 4 times 3 is 12 plus 2 times 2 is 4 minus 1. 12 plus 4 is 16 minus 1 is 15. So f of 2 is 15. 2 can also be thought of as the input, and the 15 can be thought of as the output to the function. We put in a 2, we get out a 15. I like to use the function notation. Think of the function as a little box. Here's f of x. We have an input, which is 2, and what we get out of it is a 15. Well, we don't need to just put in numbers into a function. We can actually evaluate a function at something like h, another variable. Well, what this would look like is we're simply going to remove the x and put in h. Now, I like to put the other variables in parentheses. I don't really need to do that. But there's nothing else to do here. This is simplified, just 3h squared plus 2h minus 1. So that is simply a new algebraic expression, but it's in terms of h now because we replaced the x with an h. Well, we can make it a little bit more fun if we replace it with something like x minus h. So what we would do is take out the x, put in an x minus h, square it, plus 2 times x minus h, and then minus 1. Well, what we're going to want to do now is to simplify this. And sometimes simplifying is the hardest part, as you will find out in calculus. Simplifying your algebra takes more time than doing the calculus. First thing we need to do is expand this binomial and then multiply it by 3. So expanding the binomial, we get x squared minus 2xh plus h squared plus 2x, multiplying the 2 times the x, and then minus 2h minus 1. Now we multiply through the 3 using the distributive property. 3x squared minus 6xh plus 3h squared plus 2x minus 2h minus 1. And now I closely look to see if there's any terms that can be combined, and there do not appear to be any, so therefore I have evaluated this and simplified it as much as I possibly can. Now, if you're a little bit confused as to the multiplying x minus h squared, or expanding that binomial, you may want to take a quick look at my quick math video on multiplying polynomials. You will see it listed with the other videos. All right, I'm going to give you a quick exercise here to do. do this exercise, you may stop the video to do the exercise and then start the video up and see how you did compared to what I did. So let's take the function g of x, and let's say that it is negative 2x squared plus 3. And let's evaluate this at g of x plus 4. Okay, stop the video for a moment. Okay, let's see how you did. So to get this started, we simply want to replace x with x plus 4 and then the plus 3. Now we're going to expand the binomial. So that's going to be x squared plus 8x plus 16, all being multiplied by this negative 2, and then plus 3. Now distributing the negative 2, we have negative 2x squared minus 16x minus 32 plus the 3. And the negative 32 and 3 can be combined, and we will end up with negative 2x squared minus 16x minus 29. So we have evaluated function g at x plus 4 by substituting in the x plus 4 and then simplifying it as much as possible. All right, hopefully this was helpful.